networking channel event entitled Challenges at Layer 8, Network Neutrality, the Digital Divide, and Spectrum. I sort of think of this as networking and communications meets policy. It's going to be a really interesting event today. I should say my name's Jim Carosa. I'm one of the program committee members for the networking channel. And as you'll see, our organizers really assembled here an all-star cast from around the world to discuss the topics that I just mentioned. I'm going to introduce our organizer, Henning Schulzrinne, and then hand things over to him. So our organizer for today's event, I want to thank him up front for all the work involved here, Henning Schulzrinne. Henning is the Julian, Clarence, Levi Professor of Mathematical Methods and Computer Science and a Professor of Electrical Engineering at Columbia University. I'm also very proud to say, of course, that he's a graduate from UMass Amherst. Henning's a well-known researcher to many of you, perhaps most widely known for his research in multimedia communications and real-time communications, and for his development of the Session Initiation Protocol, SIP, and the Real-Time Transport Protocol, RTP. Henning's a fellow of the IEEE and the ACM. He's received the IEEE Internet Award and the Mayor's Excellence in New York City in Science and Technology, among many other awards. But for today's purposes, on the networking channel, however, probably the most relevant aspect of Henning's background has to do with his work in networking and communications policy. From 2010 to 2019, he was advising the U.S. Federal Communications Commission, the FCC, including in his former role as the chief technologist of the FCC on various issues from 2019 to 2020. He also served as a technology fellow in the office of Senator Ron Wyden, working on efforts to protect against illegal searches, broadband availability in rural and low-income households, and preventing identity theft. So with that, Henning, and to the whole panel, welcome. Thank you all for being here. And Henning, I'm going to turn things over to you.
Thank you. Thank you, Jim, for the introduction. It's, as they say, an honor and a privilege, particularly for many of you who may not necessarily think as much about policy issues. We're going to try today to give you, as much as one can do that in an hour, to give you a taste if you want. So think of it as kind of a tasting menu. Hopefully it leaves you hungry for more detail on many of the topics that we'll be talking about. It used to be that networking was largely a technology discipline. You could focus on the technology and not miss much of great interest. The last year plus clearly has demonstrated the importance of networking in all areas to sustain some semblance of functioning, both at the kind of economic level, as well as working from home and so on, as well as in things like education, healthcare, and just simply staying in touch with friends and relatives one cannot visit. So policy, broadly speaking, is about how do we make sure that the technology serves people as opposed to just being bits and wires and fibers and radio waves in that. And uniquely, that among all the computer science technologies is that all of us have a daily exposure to that in both ways, good and bad. We will focus today largely on the issues that have to do with networking infrastructure. There is a separate important topic having to do with all the services that run on top, primarily kind of social networks and content-oriented services. That's a different discussion that we won't be having today, just given the time available. So just as an explanation, I've titled the session Layer 8. This is, for those of you who haven't seen it, who haven't seen the t-shirt, this is a standing expression for a problem which is just above the technical layers of the OSI stack in that. And I think a pure coincidence, I don't think there was any number alignment there. Indeed, for those of us with a background at US regulatory, indeed, there is a magic number 8 and the FCC, namely, this is where the commissioners sit, where the big policy decisions are made, where that has become such a standing numbering that when they moved a few years ago, they relabeled some of the floors to make sure that the 8th floor, even though it is not technically the 8th floor, indeed has number 8 on the elevator. So we'll be dealing with some of the questions today. Broadly speaking, we have across all topics 2 questions to address. Namely, first, what is the role of telecommunications carriers as providing infrastructure? And secondly, conversely, what is the role of government as this entity that might fund and regulate the private investment, infrastructure, behavior, and all that? The legal challenges, as we will hear, differ quite a bit among countries, but I hope we'll also discover that despite the history, that there's quite a bit of similarity. So what are the questions for today? And this is we'll tackle this in somewhat different order than I'm saying on the slides here. Namely, we've had a long-running discussion where probably the largest engagement of a technological community occurred, has been about network neutrality. Namely, and one of the questions, broadly speaking, is this really about packet scheduling, kind of things that engineers are comfortable with, or is it as much or more about competition, prices, and entry? I will hear first, actually, about a topic that has garnered a very large share of attention pretty much everywhere in the last year in particular, namely, how do we ensure that both rural areas and, importantly, people with lower income have access to the internet in a meaningful way? And Sonia will start us out on that question. And then one of the inputs into the networking ecosystem is spectrum, as many services or as much of the internet is experienced wirelessly through mobile devices, through Wi-Fi, in particular, that at least the last few feet, if not the last few miles, are now typically wireless. As we all know, spectrum has become the key ingredient to make that work and possibly expand and solve some of the other problems: competition and accessible availability. We have a wide diversity of panelists today to provide their perspectives in that. So we'll start out with each of the panelists giving a kind of a quick introduction to one of their favorite topics, topics they're working on, and then we'll transition into a Q&A and discussion session after they've each had a chance to introduce their topic. So without further ado, let's start with Sonia, who is the head of the digital inclusion part of the Web Foundation. And she's going to give us an overview of the important topic of ensuring access to everyone.
Thank you, Henning. Thank you, everyone. Let me just share my screen quickly here so you can all see the presentation. All right, you should be able to see it now, right? Great. So let me start then. So first of all, like I said, thank you very much for, oops, sorry. I am very sorry. I think I shared the wrong window. Apologies for that. There you go. Sorry. Can you see the screen?
Yes, we can, at least I
Okay,
can.
very well. Excellent. Sorry. Okay. So I'm Sonia George. I'm the executive director of the Alliance for Affordable Internet. And as you can all can tell from the name, Alliance for Affordable Internet, I do care and we care, not just at the Alliance, but at the Web Foundation, about making sure that everyone has access to affordable access and connectivity everywhere in the world. We are especially preoccupied with the kind of access, so not just affordability, but the quality of access that everyone has, especially in low and middle income countries, where we see that not only affordability, but the quality of connectivity remains a very serious problem, and one that most of us here on this call actually are fortunate not to experience, because we have connections, we have fast connections, probably most of the time reliable connections, multiple devices, etc. But let me give you then just a very quick picture of where things stand in the countries around the world where we work. And I invite you to check more on our websites, etc. And we'll have the discussion. We can share more details. But let me do a very quick review of where things stand right now. We publish every year something called the Annual Affordability Report, where we actually measure not just affordability, but actually policy progress towards affordable outcomes. So it's really about how countries and regulators and policymakers in those countries are progressing towards what we call a good practice policy framework. You'll hear a lot of what that looks like from others on the panel later. And the reality is that some countries are doing well, but other countries are actually doing quite badly. And most importantly, it takes them far too long to take actions that show impact fast enough, especially given, as Henning already highlighted, the pandemic and the way the pandemic really amplified the importance of digital access. In terms of affordability, it's close to about 100 countries that we now cover in our research. Only about 43 reached what we call the affordability target. And this is a very simple policy tool that allows us to understand how do countries in the aggregate fare in terms of affordability. And this is the affordability of 1 gigabyte only for 2% or less of average monthly income. I'm sure, like I said, most of you here on the call probably have a lot more than that. And not only that, at a much lower percentage of your income. That's not the reality around the world. In fact, especially if you are from lower income groups, the percentage that people have to spend of their income in some countries as high as 70%. So basically they are excluded. And what we want to make sure is that the work that we do on policy and regulation to support connectivity and access is not the kind of policy that contributes to exclusion, that contributes to inequality, but that changes that direction of things and expands the possibilities so that we can change the picture that you see here from across the world, in Africa, in the Americas, and the Asia Pacific, where while first of all, very few people, take for example, Africa, only about 29% of the population in Africa use the internet. About the same percentage have mobile broadband connections. That doesn't always mean that they're using it every day or all the time. In fact, a lot of these numbers, as they are measured by ITU and other folks, only measure the possibility of connecting to the internet once every 3 months. Imagine if that's how you had your access. I don't think it would be acceptable. So there's a couple of things in terms of who's online, how frequent people can be online, can people afford to be online, can they connect and have a connection, mobile broadband or fixed broadband in those developed countries where that's a possibility. But also, and very importantly to us, there's a lot of groups that are far excluded, including women. And so the internet use gender gap across the world is not only quite large, in many regions, in fact, is growing. And let me just make a note here that the internet use gender gap is not just about accessing a connection or being able to afford, but being able to afford a good enough connection, just like any peer, right? So just because someone is a woman, it shouldn't be that they should have less data, lower quality connection, a poor device that is not functional, et cetera, et cetera. You see where I'm going. So because of this picture and the fact that this is a very worrisome picture in the world, we at the Alliance for Affordable Internet developed the concept of meaningful connectivity. And the reason why we developed this concept and this target that has 4 elements to it is precisely because policymakers and regulators need to know what can they do to reach a better picture, right? To get to a point of the digital development in their countries where people have access to what we call meaningful connectivity, which means that they have regular access, and we actually mean daily access, with a suitable device. So at a minimum of smartphone, but ideally even better, with enough data and a fast connection. And when we say enough data, we talking about at a minimum 10 megabits, but also a fast connection. And we kind of use a proxy of a 4G type connection, if a 4G is actually what people can have, to be the minimum that people need to be able to enjoy and make decisions about how digital access can improve their lives. So, as you will see here from others on the call, the reason why these dimensions are very important is because when you think about spectrum, for example, then you need to make sure that spectrum policy is going to lead to those outcomes. When you think about quality of service and the right speed, you need to make sure that those also lead us to that. So these kinds of concepts and targets allow us to also design and develop policy that will lead us to those kinds of realities where affordable and meaningful connectivity become a reality. I just wanted to share with you here today one example of why it's important to go beyond just plain internet access, what we call a binary way of approaching connectivity, which is basically just on and offline, and with all of those other dimensions being irrelevant. The point is they are relevant because, say, for example, take a country like Colombia, where if you look at internet access as it is measured today in the world as this binary on-offline of using once in the last 3 months, about 84% of the people in Colombia are said to be internet users. The reality is that from a meaningful connectivity perspective, only 50% of the population in the country are internet users. But not only that, the gender gap that exists in the country is much greater than what it appears, because it's not just about access, it's about the quality of the access, the type of devices that one uses, etc. So what can we do? We did some work that you all are invited to take a look at. It's on our website and also on the ITU's website. We attempted to estimate what it would cost the world to bring humanity, right, online, to connect humanity by 2030, which is the target date of the Sustainable Development Goals, to the equivalent of about a 4G connection, right? This is the number. 428 billion just to get everybody to the same level playing field, right? To that level of connectivity. And we're not talking about devices here. We're talking about speed and the type of connectivity for sure. To that level of internet connection that is a starting point for people to be able to, take care of their health, education, do business, do whatever they choose with their lives as digital citizens. 428 billion over a decade to bring everybody to the same level playing field. These are investments across different layers of the network, as you can see here. We don't have time to go into the details, which I love to break it down, but today there's no time. But let me tell you something, 428 billion, this is the cost to bring everyone to that same level playing field in terms of connectivity around the world. So it's for the population of 10 years and older around the world. This is the same amount that the world spends on soda every year, just to put it in perspective. Now, what does that mean across the world, across different regions of the world? It means that South Asia requires a lot more investment because there's many more people that are still unconnected. Sub-Saharan Africa as well. But as Henning was pointing out, in the Americas, including in North America and also in Europe, there are quite significant percentages of the population in those countries that still remain unconnected and are underserved when it comes to the quality of connections that they have. This is certainly true for many of my friends in rural New England, for example, what many of you are from, and many of the other panelists I bet can attest to that. The level of connectivity that rural folks have around here is certainly not even close to these meaningful connectivity concepts. Obviously, lower income countries have a more challenging time, but others as well. Two things before I leave you that I think are important. Bringing people online and thinking about connectivity and access. It's not just about infrastructure, right? It's beyond infrastructure. We need to think
Recording
about
in progress.
everything that people need to make sure that they make the best use of that connectivity. So again, people need affordable devices. They need the right data. They also need to have the right services providing useful content and products for their livelihoods. And it's important that we make sure that no one is excluded. And by creating and investing in infrastructure is not yet another way of increasing other kinds of economic, societal, and cultural inequalities that already exist. So if you look at this chart, let me leave you with one message. It's not just about putting infrastructure. A lot of infrastructure is actually already on the ground in many countries of the world. But as you can see on the blue part of those bars on the graph, a large percentage of populations in many parts of the world, even though they are supposedly covered by infrastructure, they actually are not connected. They cannot afford, they don't have the skills, they don't have the devices. So we need to do a lot in terms of policy and regulation to get to a point where we can connect all these dots and everyone can actually enjoy the opportunity of digital connectivity. So others will give you more detail, and I can't wait for really great questions from all of you. Thank you.
Thank you, Sonia, for the great introduction. We are still having, ironically, connectivity problems to get Paul engaged, so we'll wait until he has a chance to make it work. And we'll go to Eric Berger, who will take us on a spectrum journey. Eric.
Yeah, absolutely. A journey through spectrum. This would be fun. So thank you, Sonia. That helps me take out a whole bunch of stuff that I don't need to talk about. Basically, we heard from Sonia some statistics on where the gaps are in the digital divide. And I'm going to talk today about two of those groups, the wholly underserved, where they've got access, but it's not affordable, and the wholly unserved, where they have no options at all. So, can wireless address the digital divide? In the 1990s, the communication divide was about voice. In the global South and in some developed countries, it could easily take months to years to get a phone line installed. And then there was a realization that it would be a lot less expensive to wire relatively few towers instead of every home with copper to provide voice service. And a wireless phone costs less than 1 month's service, fixed wireline service costs. So that resulted in explosive wireless growth. And in fact, in the global South, we often saw that wireless penetration surpassed what it was in the North. Now, 2G wireless was great for voice, but it's not so good for data. The 1990s saw the expansion of the wired internet and the beginnings of the data society, which really exploded in the 2000s in more developed countries. When 3G hit, it was a lot less expensive per data bit than 2G, but it was a lot more expensive per subscriber for voice. And even when you considered that 3G gave us a high wireless data rate, that was about 1 megabit per second, which was no match even for DSL, which today we don't consider to be broadband. So something that's changed is with 4G LTE, and more especially 5G, we have data rates that in some cases rival fiber, and in most cases are more than enough for broadband access, that kind of continuous connectivity and useful connectivity that Sonia talked about. So then that brings us to spectrum. Basically, and very simply, if there's more spectrum available for low or no cost, that means that there should be more potential for providing wireless service for low cost. 5G high band and unlicensed high band, like 60 gigahertz, was relatively unused, but in short, we are out of unused spectrum. Also, those high bands, high frequency bands, are pretty much limited to outdoor use and directional fixed wireless access. It needs a lot of radios as there are severe propagation limitations. And to give an example, for municipal deployments, we are talking about a radio on every block or even every lamppost. And that is still pretty much for outdoor use, not in-home use, unless there are 5G high band to Wi-Fi antennas on the window. Also, if you're wiring every lamppost, you're almost wiring every building anyway. Low band is already being mined by the operators in transition from LTE to 5G. And mid-band, I mean, the good news is it is just right for modest building penetration and decent distance. But what makes it just right for communication makes it just right for radar systems, like for aviation and weather measurements and prediction. And I think I do want to be sure to clarify here that when I'm talking about spectrum, it's not just for mobile cellular. It's also about modalities for low Earth orbit satellite, fixed wireless, and so on. So how did we deal with spectrum? Historically, spectrum sharing has been by geography. There are basically two kinds of systems: high-powered, wide area systems, and these would be managed by an operator who would get a license from their national regulator, and that licensing would guarantee non-interference in that geography or prosecution if someone steps out of line. And then that operator would work out sharing what they would call their spectrum with their customers. And because you have basically a manager managing who can use the spectrum when, they could give some quality of service guarantees. The other kind of system are low power local area systems. And here they tend to be managed by the devices themselves. And the great example there is Wi-Fi or Bluetooth. Unlicensed operation does mean that the service works great most of the time, as long as you don't turn on your leaky microwave oven. And if you are in a high density multifamily unit, you also can expect a lot of congestion. To deal with legacy incumbents like satellite earth stations, airport radar, basically what the regulators would do is they would not give a license near those locations to protect the incumbent. Either that would be forever or until they moved. The other thing is we historically considered spectrum as a fixed limited resource. So regulators would think about things like the average revenue per user of a fixed scarce resource, because they wanted to make sure that the carriers who do that low-level spectrum arbitration could stay in business. But it also meant, because they're giving exclusive licenses of what's essentially a public good, they wanted to make sure that the carriers operated broadly in the public interest. Today, there's more of a techno-regulatory approach. So for example, if there's no more easy spectrum to allocate, let's make more. The United States deployed a novel approach in 2020 called CBRS. Here, a spectrum access system basically senses when the highest priority user wants to or is using the spectrum. And when that happens, they basically signal all the other radios in that geography to turn off. Likewise, there are priority users that operators can license what we call priority licenses. And basically when the highest priority users, those are federal users, aren't using the spectrum, But the priority user wants to offer, say, like a quality of service kind of service. Basically, they can kick the unlicensed users off. But the reality is most of the time, there's a lot of room for the unlicensed users. And so they can have relatively unencumbered service. The downside of CBRS, it's a very complex system and it's very expensive to run. So if we look to the future, DARPA, one of the US military's research organizations, completed what we call the Spectrum Collaboration Challenge. And one thing that did was it demonstrated that we can use AI techniques when we're in a, how should we say, competitive, cooperative, unlicensed spectrum regime. And that we could basically set things up to have a much better experience for all users. And that's true. And one of the parts of the demonstration was even when we're filling in the gaps in licensed spectrum. So when the licensed operator is not using it, we can still fill those gaps. In the US, another thing we did last year was in the 3.45 gigahertz band, we demonstrated that a light touch sharing regime between the US Department of Defense and non-federal users is possible. And we're seeing the auction for that in a few months. And then finally, along for some of the people on this program, regular listeners are possibly aware of it, the US National Science Foundation has some initiatives such as the Spectrum and Wireless Innovation Enabled by Future Technologies program, or the SWIFT program, and the National Center for Wireless Spectrum Research, or the SII Center program. These are looking to create even more technology to lower the costs and barriers to wireless broadband deployment. So that's kind of the state of wireless and wireless spectrum sharing in the US. I'll hand it on back to Henning for others.
Thank you, Eric. We have next, I think we had Scott, if you want to go ahead, and then we'll wrap up with Chris.
Okay, well, thank you very much, Henning. Very nice to be here today. I thought actually that I would provide more of a broad brush treatment. I spent the first 30 years of my career working as a network designer and network engineer in the United States. About 20 years ago, I went over to the dark side. I live in level 8. I concluded that much of the decisions that I was interested in weren't really technical decisions. They were policy decisions. They were economic decisions. These days I work as an economist based out of Brussels, Belgium. So if you're doing actual regulation, what are the kinds of issues that policymakers, that regulators have to think about? I would contend that a large fraction of what real life regulators spend their time with involve three main issues. The first one is dealing with market power, monopoly power, for example. A second relates to public goods, ensuring that things that ought to get built, in fact, do get built, including data networks. And a third has to deal with management of scarce resources, of which the best example is indeed the spectrum that Eric was just talking about, spectrum management. So why do we have these issues in the first place? Well, a core issue is, especially for fixed networks, that there are really a bottleneck facility. How many wires do you have coming into your house that are actually capable of carrying communications? For a lot of us, it's one. For people in places like the United States and Canada and a few other places, often it's two, because there'll be a telecoms company and a cable company. But you've got scarcity. And to an economist, scarcity implies frequently market power. Most of these fixed networks gravitate one way or another towards a system of natural monopoly. And we've seen that in different ways in different countries. In North America, you historically had a bell system. In Europe, most countries have had government-owned monopolies, so-called PTTs. You might think that a government-owned monopoly is trying to benefit the people, but the practical reality is the fundamental problems in monopolies are the same whether they're publicly owned or privately owned. You tend to get high prices and low innovation. So what we've had globally in developed countries in particular is a strong tendency over the years to move from these government monopolies to a system where networks are privately owned and managed, and where as much as possible competition gets introduced. And usually that gets done through some level of regulatory obligations imposed only on telephone companies, only on network operators that have some degree of market power, pricing power. So the small companies don't get regulated, the big companies do usually. And that's worked pretty well where it's been done. All of Europe works on that system, and all of Europe has been pretty effective in implementing competition in countries that historically had only one network operator in most cases, for large parts of the country, if not for all. So that's one of the fundamental approaches taken, but it has some downsides. It means less revenue coming into the network operator, and these systems are expensive. Now, Sonia was focused largely on mobile services. Eric was focused largely on mobile services. Those are very important. And in fact, in large parts of the world, as Sonia said, they're far and away the most important. In many of the lesser developed countries that I deal with, you've got good connectivity in the big cities on the coast and very little when you get to the interior. Many parts of those countries are not going to be wired up in our lifetime. The mobile services are the only game in town for a lot of people throughout the world. But for many of us who have the luxury of living in better developed countries, getting the fixed network built out is crucial. And there's a challenge. Getting more stuff rolled out typically requires civil works. It requires guys with hard hats. It requires tractors that can dig trenches. That's expensive. It's very expensive everywhere. So this has been a very fundamental challenge in getting things rolled out. And the question then becomes how to close the gap. So again, the approach in most developed countries, many countries really, all of Europe, has been to enable competitive entry. The competitive entry means prices go down, innovation increases, companies are motivated to build. But there are limits. The companies make only so much money. In most countries, there's not enough commercial incentive to get the whole country covered. You've got a couple of reasons for that. The biggest is differences in population density. In parts of the country that are dense, it's easy to get things built out. You've got relatively short lines that are not so expensive. In a lot of the country, you've got remote areas. Places like the United States have big empty spaces, relatively empty spaces, that are very expensive to wire up. So getting fixed connectivity is a much larger challenge, a much more expensive challenge, and it has implications. So basically, if we look at the approaches that were taken in these regulatory systems, there's a bit of a tension, since they're bringing prices down, which is good for consumer welfare, but it also means there's less incentive for the companies to build out. The difference has to get filled in somehow. Often that's done through public subsidy, which however has to be done very carefully because you don't want to crowd out private investment. The subsidy needs to be carefully targeted only at the places that wouldn't get built out. And it generally also requires a level of regulation, somehow loosening up enough that you, on the one hand, deal with the constraints of monopoly, but on the other hand, try to provide enough incentive that the companies will build out as much as could be built out by private companies, and then the rest has to be filled in with subsidy. So these are the key issues that real policymakers deal with day by day, actually, in trying to get full connectivity to their national territory. A key point that Sonia made, though, is that's the deployment side. That's the supply side of the story. There's also big issues on the demand side, ensuring that people who could get broadband actually order it, that they can actually afford it, and once they can get it, that they have the skills, the knowledge, and the interest to use it. Surveys on both sides of the Atlantic make very clear the biggest reason for people not to have broadband today isn't lack of supply, and in most cases isn't lack of money. In most cases, the biggest impediment is either that they lack the skills or that nobody in the household sees the need for it. So there's plenty for policymakers to do. And with that, back to Henning.
Thank you. Chris, you're wrapping up.
All right. I'm sharing, I hope. Everyone can see the slides?
Yep.
All right. I'm going to set my timer for 6 minutes because I'm standing between you guys and asking questions to the people you actually want to hear from. All right. So I'm going to talk quickly about the law. I'm not your typical lawyer, as others will confirm. I'm from the University of Sussex in the UK, and I'm going to talk a little bit about net neutrality law and regulation. As Scott said, there's a lot more to this than just saying, let there be access. So you're all familiar, I think, with God as represented by Monty Python. That's actually W.G. Grace, the cricketer. Most of the world now agrees, it seems, maybe excepting this audience, that net neutrality laws are a good idea. But when they say, of course, it's a good idea, they don't mean they actually want this to happen. They just mean, let's have a law and let's not enforce it. And I wrote a piece 3 years ago for Communications of the ACM, a viewpoint saying that actually, unless we measure this thing, we don't even know if there's a problem, let alone a solution. I think that's pretty much where we are still 3 years later. So net neutrality laws became all the rage about 10 years ago, introduced in various different places. The United States is weird about these things. It sort of has some through mergers and acquisitions, and Biden is now trying to reintroduce some of the standards that existed. UK has always gone for self-regulation, and post-Brexit it may go back to that position. But you can see generally a move towards introducing laws and then dealing with cases of zero rating. And in Europe, across the European Union and the European Economic Area, we have a regulation of 2015 on open internet access. The words net neutrality could not be uttered. And so the European Parliament agreed to a law on open internet access, which actually is net neutrality, but they didn't want to call it that. But the problem we have is enforcement. So far fewer have any regulation. A lot of people have said this means we have Schrodinger's net neutrality. We have a law that says there is net neutrality, but because we can't see inside the black box of networks, we actually don't know whether or not the network is actually neutral itself. And that's what I'll focus on here in the last 4 minutes. So we know longer term there's no problem, and we've talked about the technologies when it comes to spectrum, or also when it comes to wired technologies. We know that getting these things done is expensive and requires, frankly, a lot of guys digging holes in the ground. That tends to be the most expensive thing, or building little poles in different areas. But longer term, of course, we know that we're all dead. And we do know that the problems that happen, whether it comes to COVID or anything else, are actually leading us towards solutions driven by governments. And one of the things that government's being told is that there is a problem with net neutrality. We've faced this before. I briefly worked for WorldCom. A few of us have brushed against WorldCom back in the old days. Remember the idea that internet traffic was doubling every 100 days? I think of that as the original commercial lie of the internet, because of course it wasn't doing, and that's Bernie Ebbers' stock price as it went north and south. But for developing nations, we actually survived the pandemic pretty well. This is the UK, this is the Ofcom, the UK regulator graph showing the increase in speed and the fact that actually we're doing quite well. Which was as predicted. And you can actually see little blips there. On the right, you can actually see a graph. And by the way, I'll share these slides afterwards. You can see a graph showing a couple of blips. So you're unlucky if you were using, in particular, the TalkTalk network in the UK. But this is microscopically, this is March of 2020. And you can see that the networks actually survived lockdown through the first part of the pandemic pretty well. There was a panic in March 2020. It was not net neutrality. A lot of people, you can see Rosalind Layton there, suggesting it was about net neutrality. It really wasn't. It was the European Commissioner asking Netflix and YouTube to stop streaming ultra high def during work hours, but they can continue to do so in the evening. And of course, as we know, congestion on our home networks tends to happen in the evening anyway. So odd moment there. And it's lucky for those of you who are not living in developing countries. Sonia's already told you about this, but I just want to focus on the fact that 37 of the 50 fastest broadband average speeds are in Europe, 10 Asia Pacific, 2 North America, 1 Africa, 0 in South America. I've done a lot of work in Brazil, for instance, where that's a real problem. 141 countries have average speeds below 10 megabits per second, which is what Ofcom considers reasonable speeds. And the problem that we have tends to be about vertical integration. The network operator pals up with content or application provider, and that gives them the incentive to discriminate. So example, in Europe, Deutsche Telekom proposed to impose download limits for customers when they reach their limit for a month, while exempting the traffic generated by its own video on demand service. That's a classic example of what we call zero rating. And the future of net neutrality is actually about whether there will be any enforcement on these zero rated products. Another example of a zero rated product, of course, is where a mobile company gives free access to some part of Facebook or WhatsApp or Instagram, some part of the Zuckerberg empire. There has been an attempt at law to enforce this. This is a judgment that came out of the European Court, which is the highest court equivalent to the Supreme Court, I guess, for the US, in September of 2020, telling a subsidiary of Telenor, the Norwegian mobile company, that they had violated the law, Article 3 of the open access law. Essentially, they said that zero rated products were incompatible, where they were blocking or slowing down traffic to limit the exercise of end users' rights, and where it was based on commercial consideration. So you can see that taking place. Is the UK about to change? There is some rumors the UK might move away from having any rules on zero rating at all, but watch this space for that. And there's some references for you, and I believe I've done this in 10 seconds, less than 6 minutes.
Thank you. Appreciate that. You've kept us somewhat on time, even though we only got now 12 minutes left to do the discussion. So I wanted to make sure that we cover our audience question that you can type into the Q&A feature in your Zoom program. We have currently one question. I suspect there's a few more that, based on the discussion so far, that we'd like to add, but before we do that, let me make sure that's an interesting one, because it actually intersects, I suspect, the first and the last presentation. So I want to give both Sonia and Chris a chance to talk about that, because I think it raises issues on both. The question is, namely, two end-to-end business model where you have a notion where, if I interpret correctly, where essentially, instead of the customer, the end user, the subscriber to the mobile service pays, that there is the equivalent of what in the US would be called an 800 number, where the company pays for the service, for connectivity, presumably partially for, and primarily for metered services. Sonia, any thoughts on whether that can be part of a solution, essentially reversing the charges, if you want to call it in telephone language?
That's a really cool idea. That's what I can tell you. And that's what a lot of people have tried with a free Wi-Fi, right? I mean, Eric can tell you a lot about that and others here. But if you think about, some of the public access and free access options that have been really important in many parts of the world, that's precisely because of that. Can you do that kind of situation as a business model? I would doubt. I would have, I think we would need to look at that. I'm not sure if there's a particular context to the question. What I would say is that what we've learned from a lot of research and from understanding the experience of people around the world when it comes to affordability is that, and I think it was Eric or Scott maybe that mentioned, it's not always about affordability. Affordability is critical. And when you're talking about low-income populations, is by far the most important barrier today. But when people can afford, they want to have more. They want to be able to choose what they want. And I think that's what's important here. From a policy perspective, so that those who are in the audience can also think from that perspective, a lot of times you think about intermediate steps. So for example, just to kind of be a little controversial here with the point that Chris was just making, zero-rated public services is a fantastic idea. Public services should be zero-rated. There's nothing wrong with that. People should be able to have access to public information without having to use their data allowances, right? And so if you think about it in that way, shouldn't everybody have free access, Wi-Fi or otherwise, to be able to have access to those public services if governments are providing services through digital platforms instead of other ways that people can access? So if you turn the problem around, you start thinking, okay, maybe this is not a solution that can happen everywhere, anytime, but maybe it is a good solution in some situations. As things develop, maybe the business model will also develop. I hope I answered the question. I don't think it's as simple as yes and no. Can it happen? It really depends on the reality that you are talking about. But I would always support a public access, free Wi-Fi, free access option, especially in places where without it, people will remain excluded.
Okay, thank you. I mean, this wasn't referred to that, but I don't want to get into it too much. It was a fairly controversial proposal and actually implementation a number of years ago. And I think it was called Free Basic that Facebook was doing, which very much broad the network neutrality angle and was eventually essentially curtailed, abandoned in India, where it was tried at least. So, Chris, I would, from your perspective, what do you think of these other economic models that are not quite like what you talked about on the data side, but are more explicit 800 number style, if you want to take free phone, whatever the version is, which has a long tradition in public services as well as in private services as well from a network neutrality perspective?
So three things. The first is that, of course, a lot of this very basic connectivity we're looking at is really too cheap to meter. And we've faced this, so Scott can talk a lot more about this than I can, but, you know, for the kind of trickles of data that are required in order to use WhatsApp or to use a very stripped down text service is so low. Well, we all remember, right, that actually texting was originally meant to be the engineer's means of using a back channel. It wasn't even meant to be commercial. We know that was an extremely low cost, but extremely profitable means for the mobile companies to operate. I tend to think of it as the 21st century telegraph, the idea that somehow a 160 character message could be charged 10 cents at one point. What a dream that was for mobile companies. So that's the first thing, too cheap to meter. Second thing, let me just introduce you all to a concept which I've talked about for a few years now, which is zero washing, where the owner of a social media company, let's call him Mark Z, decides to walk into a country and he says, why don't we offer flat rate, free access to basic services? We'll give you your mobile health app. We'll give you your mobile community app. Maybe it'll be a COVID check. And alongside it, let's just offer, you know, people some stripped down version of Facebook and WhatsApp, and that'll be free as well, but no other social media app. And he's been doing that for years and years and years. And Henning, you're quite right. In India, they stopped doing it because it became illegal. 2017, India introduced the toughest net neutrality laws in the world because they didn't like the zero washing stuff. And they actually sent him home saying, we've had enough of rich white guys telling us that we should feel privileged at getting something free from you. And we know that it isn't. And the third thing to say on that is that we've tried all kinds of different models. In Sweden, they actually tried a model where, do you remember this advertising on your phone call model for students? So if you wanted to get a free phone call in your student dorm, you had to listen to an advert first before you got connected. So I'm not quite sure exactly what the business model is. It sounds like we're talking to someone who's got a startup idea here, but these things have been tried many, many times before. Too cheap to meter, zero washing, and yeah, look at some previous business models. But Scott will know a lot more about the too cheap to meter.
Yep. Do we, I mean, I want to give, we are very close to running out of time, so I want to give Scott a time, and then I want to briefly handle at least one spectrum question that's been in the chat, in the Q&A. So Scott, you want to just finish the discussion?
Just a very quick word. I certainly agree with what Chris was saying about too cheap to meter. I wanted to say, coming back to the first question and also related to the Rudolf Vanderberg question near the bottom, it seems to me that this question of end-to-end quality of service is something that's been rattling around for a while. You know, 20 years ago, we had an RSVP, technically very interesting design, people like Dave Clark at MIT pushing it. You know, as far as administration, it was a bear. But the biggest reason why it never saw widespread deployment was that the business models for paid interconnections between the network operators never really came into place. There was never really a clear business model that made sense to everybody. The question that Rudolph raises is, what about termination fees? Some of you will recall that about 2013 or so, many of the European phone companies, telecoms operators, the big incumbents, were pushing hard for termination fees for data. And not surprisingly, many developing countries like this, because they would tend to be on the winning side of this, would tend to impose charges in the end on US-based digital platforms. But for a number of technical reasons, I thought it was a bad idea. Still, the issue, I think the core of what I said in the first place, a lot of these things in the end aren't really about technology. They're about the underlying economics. That's what actually drives a lot of what happens. Thank you.
Okay, I do want to, just in the last minute or so, I want to address some of the spectrum relations question. Rudolph Vanderberg asked about license-free spectrum for private LTE and 5G in that. And Eric, you spoke to that a little bit in the CBRS context as kind of being in that example. Maybe you can elaborate just in the minute or so that we have.
That's right. And I can also touch upon Mr. or Mrs. Ms. or their anonymous question as well. There is a bit of all of the above here in that in the CBRS auction, I mean, a typical auction in the US gets tens of bidders. And in fact, many of those are actually different variants of Verizon or AT&T. The CBRS auction had tens of thousands of bidders, entities that had never bid before. And by the way, as Scott will tell you, if you're bidding on this license, you're required to be building. You're not allowed to buy them to resell or buy them to hoard. And in fact, what caught my eye during it, and I actually called a friend of mine at the FCC saying, what the heck's going on in West Texas? Because we denominate these licenses in dollars per megahertz population. And the idea is if you have a lot of population that's served with some spectrum, that price goes down, or you get more bandwidth to have higher speed. The price was 1,000 times higher than like the rest of the country in this one little parcel in West Texas. And basically they said, go look at satellite view on Google Maps. And it was an oil well. This was not I'm going to offer broadband service in East Los Angeles. This was, I need highly reliable. And so that's where we see like private LTE, private 5G, CBRS on both the license side, but also if you don't need that reliability, they needed the reliability in that instance. But if you don't need the reliability and best effort is good enough, that's part of the beauty of the new organization of 5G.
Okay. Clearly, we have had a big, good taste of various topics, and I hope the audience has maybe gotten an appetite for a longer, more extensive meal, but we're out of time. So, Jim, take it away.
Okay, well, thanks to all of you for just a really fabulous and fascinating hour. It was really great. And this is being recorded, and there are a number of resources I think that the speakers are making available. So thank you all for that. We wanted to say that this is the 6th and final event of the inaugural, I suppose, semester, if it were the spring and into the early summer, for the networking channel. And so for those of us who live in the Northern Hemisphere, it's summertime. And that means it's time, time for breaks, and schools and universities are sort of shutting down for a couple of months. Well, at least classes. And so the networking channel is going to be stopping for the summer. We're going to be back online September 15th, 2021 with a set of new events. So stay tuned and please check out the website for what those future events are going to be. And by the way, if there are topics that you think would be of interest, by all means, go to the networkingchannel.eu, send us your suggestions, and the program committee will be meeting over the summer to fashion the fall program. So thanks again to all the panelists. It was just a really fabulous hour. Thanks to Henning for the organization. And we'll see you all again, hopefully, and many more on the networking channel come September. Thanks again.
Bye, thanks.
Recording.